Hey guys, so I was asked to record some of these problems that you guys are doing, so I figured that I would do some of them that are a little bit higher up or further along in the periodic table, just so you can get an idea of these types of problems, okay? So I'll probably end up doing 3 problems from the worksheet. The first problem that I'm going to do is basically silicone. Okay, so it is asking you for the atomic number of silicone, and then it is asking you to make the orbital diagram and then figure out the quantum number. So to figure out the atomic number of silicon, you're going to take a look in your periodic table. And if you look, it looks like the atomic number is 14. That means that it has 14 protons. So in turn, we know that it is a neutral atom, which means if it has 14 protons, it also has 14 electrons. Okay, so now I know that I need a spot for 14 electrons. So now I'm going to use Aufbau's principle and I'm going to lay out the orbitals that I need to use. So the first orbital that has the lowest energy is going to be 1s. The next orbital after that is going to be 2s. And then after that is going to be 2p. And then we are going to move on to 3s. And then we move on to 3p. Okay, so the s orbitals are going to hold 2 electrons. So 1s contains 2 electrons when it's full. 2s contains 2 electrons when it's full. 2p when it's full is going to contain 6 electrons. 3s when it's full is going to contain 2 electrons, and then 3p when it's full is going to contain 6 electrons. So if I take a look at my total, I have 6 and 6 is 12, and then 14, 16, 18. So I'll be able to hold 18 electrons, which is perfect because I just need to find a home for 14 electrons. So I know that when I'm drawing my orbital diagram, I'm going to go all the way to 3p. Okay, so now let's draw it. Let's get rid of some of this commotion here so that you guys can follow along with me a little bit more closely. Okay, so here we go. We're going to draw our first orbital, which is 1s. The s orbital has 1 orbital. You draw 1 line, and you're going to put 1s underneath it. Let's move along to the 2s orbital. The s orbital has 1 orbital. You'll have 1 line, and you'll write 2s underneath that. The p orbital has 3 orbitals, so you're going to draw 3 lines, and then you will put 2p underneath it. Then the 3s orbital has 1 orbital, so you will draw 1 line and you will put 3s underneath it. And then just like 2p, 3p has 3 orbitals, so you'll draw 3 lines and put 3p underneath it. Okay, so now we know how many orbitals we have to draw to complete our orbital diagram drawing. Okay, so let's add our electrons. So the electrons are going to add according to 3 rules. It's going to add according to Aufbau's rules. It's going to add according to Hund's rules. And it's going to add according to Pauli's exclusion principle. Okay, so those are the 3 rules that we need to be aware of when we are doing these diagrams. So Aufbau says we're going to add from the lowest and then move on to the highest. So the lowest orbital is going to be 1s, and in this drawing, the highest that we're going to be drawing is 3p. Basically, what it's telling you is we have to fill the lower energy levels first and then move on to the higher energy levels. For Hund's rule basically says that we are going to come into the orbitals one at a time, and then after we have filled the orbital, then we're going to pair. Think about it like you're getting on a bus, right? And there is somebody sitting in the first seat, right? Nobody ever wants to sit next to somebody on the bus, so you're going to find the next empty seat to sit at, okay? So think about it that way in terms of how electrons add to the orbital. And then we have Pauli's exclusion principle, which basically says that when electrons enter into the orbital, if you are paired up, you are going to have opposite spin, okay? So let's add our electrons. First electron comes in, it's going to add into the 1s orbital. It's always going to enter in clockwise, so it's going to be an arrow up. Then the second electron, remember, we have to fill 1s before we can move on to 2s. The second electron is going to come in, and it is going to come in an opposite spin according to Pauli's exclusion principle. So then that is going to be down. Now that we filled 1s according to Aufbau, we can move on to 2s. The third electron comes in and it fills, and it comes in clockwise. The fourth electron comes in and it's going to be counterclockwise, meaning that the arrow is going to be in the other direction. Okay, now let's keep on moving along according to Aufbau. Our fifth electron that comes in, now we need to pay real attention to Hund's rule, especially for the P, D, and F orbital. Okay, so when the electrons come in, remember, you don't want to sit in the same seat as somebody else if you can't help it at the bus stop, on the bus. Okay, so the electron is going to come in. It's going to come in clockwise and fill in the first orbital. The sixth electron is going to come in, but it is going to go into the next orbital. And then the seventh electron after that is going to go into the third orbital. All right. Now that each of our orbitals has one electron in it, now we can start to pair. And they're going to come in opposite spin. So we go down, down, and down. Okay. And now 2p is full. Now we move on to 3s. The first electron always comes in clockwise. And then remember, the second electron is going to come in an opposite spin, which is counterclockwise. Okay, 3s is full. Now we need to figure out how many electrons we have left. So we have put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we found spots for 12 electrons. That means we have 2 electrons left. And they're going to go into the 3p orbital. Okay, so according to Hund's rule, we add one at a time and then we can pair. So we are going to add in that 13th electron in a clockwise manner in the very first orbital going up. And then that last electron, which is the 14th electron, right? It's not going to add to the first one because each orbital doesn't have an electron yet. So it's going to add to the second one, and it always adds clockwise, hence why it's up. Okay? And then, as always, you're going to circle the last electron that you drew. All right, so that is the orbital diagram for silicon. All right, so now we need to figure out the quantum number. Where are these electrons located? What is their address? All right, so if you remember, the first quantum number is going to be the main energy level. It's the distance away from the nucleus. So if the nucleus is here, the furthest one out is going to be the 3p orbital. So that means that the first quantum number comes from that number that is in front of the last orbital that you drew. So guess what? That 3 is here for our first quantum number. So that first quantum number is 3. The second quantum number has to deal with the shape of the orbital. So we are in the p orbital. According to your chart, the p orbital is going to be dumbbell shape. Hold on, I can't spell today apparently. Is going to be dumbbell shape, which means that we represent a dumbbell shape according to your chart with a 1. Okay, so the p orbital for the second quantum number will always be 1. The next one is going to be position in that p orbital. So if you remember when I was telling you about the p orbital, there are 3 different p orbitals. We have px, we have py, and we have pz. And each of them has a number that's associated with them. The middle orbital is always going to be 0, and then you're going to put the numbers from there. So on the left side, that's going to be a -1. On the right side, that is going to be a 1. Okay, so if you look at the last electron that you drew that circled, it is in the py orbital. The py orbital is designated with this 0. Okay, so this 0 comes down here, and that ends up being your third quantum number. Okay, now the last thing is going to be spin. So if your electron is facing in the up direction, that means that the spin is going to be clockwise. To designate a clockwise spin of an electron, that means you're going to use the number +1/2. So over here for your last quantum number, it'll be +1/2. Okay? And then when all is said and done, This is the quantum number for silicon right here. 3, 1, 0, and plus 1/2. Hopefully that was helpful for you.